Hello, my name is John Kelly and this is the Weber Auto YouTube channel. In this episode we are going to look at personal protective equipment and tools, high voltage tools, for use on hybrid and electric vehicles. So to begin with, let's start with the personal protective equipment. There are laws and regulations and standards that are intended to protect you as a worker when you're working around hybrid and electric vehicles, what we call high voltage in the automotive industry. Now I realize in the electrical industry our voltages are pretty low, but for automotive voltages these voltages are pretty high, upwards of 700 volts that I've seen on some hybrids. So compared to the 12 to 14 volt system that we're used to working on, that's high voltage. Well, OSHA, the Occupational Safety and Health Administration, has laws that require your employer to make sure that you are trained annually and that you are provided with access to the proper personal protective equipment to protect yourself as you're working on these vehicles. So, what the law tells us, and this is OSHA standard number 1910.132 here in the United States. It tells us basically that the employer is responsible for paying for the personal protective equipment that you use in your shop. Now there are exceptions to that. If you, for example, have some personal protective work boots that you wear after work and take home, then they don't have to pay for those. But if you go to work and change your clothes into work purchased clothing and boots, then they do have to pay for it. Employers are required to pay for some sort of eye protection. Depending on what type of work you do, you might require a different type of eye protection. The eye protection must be a certain type of eye protection. There's a standard from the American National Standards Institute, or ANSI, and the standard is the Z87 standard for personal protection. And what it does is it helps employers meet the OSHA regulation for eye and face protection. So, on your safety glasses, these glasses right here that I have are safety glasses. They are supposed to have some side shields on them to be full protection. These, of course, are safety glasses. They have the side shields on them also. But if you look here on the side of the eyeglass, this one reads ANSI Z87 Plus, and so Z87 is a standard, and there are different years of that standard. The plus means it's a high impact resistant pair of safety glasses or goggles. Now for my prescription eyeglasses, it's a Z87-2 Plus. So the -2 tells us that the minimum thickness of these lenses is 2 millimeters. So prescription safety glasses are a little heavier than the regular eyeglasses that you might purchase, but it saves you from having to wear another safety glass over it unless a face shield is required. All right, so safety glasses, eye protection, of course, is required for most employers anyway, but especially working around hybrid and electric vehicles. And then clothing. You should be wearing clothing that doesn't combust easily. Cotton clothing is recommended because of how slowly it burns and it resists burning. And then footwear. I've got a boot here that I bought, well, it's been 3 years ago, for this class for a demonstration, and this is a safety toe, non-slip, oil and slip resistant electrical hazard boot. But if you look at the tag on the inside of the shoe here, it reads ASTM, which is another standards organization, and then F2413-11. So if we look up what the ASTM 24-11 standard means, it tells us that this footwear meets the performance requirements of that particular law issued in 2011. Now the second line reads MI75C75. The M means it's meant for male. If it had an F there, it would be for female. The I stands for impact, and the 75 stands for 75 foot-pounds. So that tells us that the safety toe here in the boot can stand an impact of 75 foot-pounds of force. So that would be 75 pounds from 1 foot up, or from 2 feet up, that would be 37.5 pounds, and so on. So it can handle an impact of 75 pounds from 1 foot, and then it gets smaller and smaller the higher you go above that. And then the last line here on the tag is EH, and that stands for electrical hazard. And electrical hazard means that the boot is capable, and this is a dry boot, not a wet boot, is capable of withstanding an application of 18,000 volts at 60 hertz for 1 minute with no current or leakage current in excess of 1 milliamp in dry conditions. So I know this kind of sounds boring, but protecting your life should not be a boring thing. You need the right shoes, the right clothing, the right safety glasses or face shield, and then the proper gloves we're coming to next here, and then we'll look at the tools and so on. All right, I have a box of brand new high voltage Linesman gloves. These are class 0 gloves, and they are rated for 1,000 volts. These gloves can be damaged instantly if you don't treat them with care. These gloves are only certified to be able to withstand that high of a voltage with no current leakage going through to your skin for a certain amount of time before they need to be recertified. So here is a box of gloves I bought last year for this class, and you notice that on the box right here it has a date of 9/16, September of 2016. And that is the shelf date. And so the way the standard reads for Linesman's gloves is that they can sit brand new in a box for a year and not have to be recertified. But the first time you open the box and take the gloves out of their special wrapping and expose them to the atmosphere, then from that moment forward you've got 6 months before they need to be recertified. Now it tells us right on the glove itself that it was tested September of 15, and then on that red tag there it tells us that it's a size 10 glove. It has a ANSI and an ASTM standard, class 0, and there's class 00, and there's a bunch of other classes for different voltages. Maximum use voltage is 1,000 volts AC. And so that's considered low voltage in the electrical world, I've been told. And the voltages go much higher than that. But for automotive, hybrid and electric vehicle use, the 1,000 volt glove, the class 0 glove, is what you need. Now the size 10 there, if you're not sure what size glove you need, just measure the circumference of the palm of your hand here. If it's 10 inches, then you need a size 10 glove to fit properly. But anyone who's ever worn these gloves for a very long time period at all knows that they get real hot and sweaty on your hands in just a short time period. And so I would order maybe a half size or a full size larger so that you can wear an inner cotton liner glove to help keep your hand cool. Now, just a quick review on the glove expiration date. So this box here that I just got yesterday in the mail, ordered these brand new, has a date of June of 2017. Now, as soon as I open these, then I have 6 months before I either need to buy a new pair of gloves or send these out to be recertified. So don't get all caught up on the date that says tested on there. Initially, when we started teaching these classes 10 years ago, we thought that you only had 6 months from the date on the glove. Well, that is not the case. It's 6 months from the time that you open them, as long as the date on the box is not more than a year old. I know that's confusing, but anyway. So these gloves here are more than 6 months old out of the box and are not safe to use and should not be used without having them recertified or just cut them up and throw them away so nobody else will use them. Okay, so let's open this brand new box of high voltage gloves. These are from Salisbury. So we open them up. There's a nice plastic bag that they come in. Hang on to the box, hang on to the plastic bag. I found that that's by far the best way to store the gloves. If you just leave the gloves laying out in the open, the ozone in the air, the ultraviolet light from the sun will deteriorate these gloves very quickly, and you'll ruin them quite easily. Plus, you should never have them folded or wadded up somewhere. They always need to be laid out flat and straight when you store them. So these, as you can see, are laid out flat and straight with the openings opposite of each other in the bag. So we'll just pull these out of here. These actually say right on them, tested 6 of 17. So that matches the date on the box right there. So they were tested June of this year. And now I have until December. Well, no, I'm breaking my own rule here. I didn't open them until September. Today is September 8th, 2017. So I have 6 months from September 8th to use these before they need to be recertified. But these gloves need to be tested every single time you use them, or before you use them. So let me put the bag back in the box so we can store them again. And let me show you how to test these gloves. So first, look at the glove, make sure it's clean and dry. We don't want anything on the outside that is conductive that your arm could touch, that could bypass the high voltage glove and get to your arm anyway. These need to be good and clean. Another thing is to look for any cracks or cuts, pokes, scrapes, anything, on a car, how everything is sharp that you're working on. It's real easy to damage these gloves. So because of that, you'll actually end up if you want to preserve the life of your gloves, you'll actually put a leather over glove on the outside of them, while at the same time you're wearing a cotton inner liner glove. So you actually have 3 gloves on at the same time. But let's learn how to test these gloves. The easiest thing to test is for a leak, and just blow some air in it. I just kind of pinch the end here. Leave a little passage to blow some air. and then I just roll it up. So I'm rolling, so I'm inflating the glove itself, and then I'll listen for any leaks, look for a leak. If the glove deflates, then there's a leak somewhere, either in how tight your sealing is here on the end, or there's a leak in the glove itself, but you need to retest it and make sure it's good. Now, Salisbury also sells a glove inflator. And when I first saw this in their online catalog, I thought, well, what is that? That's kind of silly, because we can just blow them up right there with our hand and mouth. But when I ordered this thing, I was actually impressed with it. So what it has is a bellows here and a one-way check valve in there. So it's going to blow air up through and inflate the glove. And then we attach the glove. There's a Velcro strap right here. We'll take one of the gloves and stretch it over this cap. Just like that. This glove will pop off as we're inflating it if we don't put this strap on here, this Velcro elastic strap, to hold it down. And even then, you're going to need to hold it, keep it from flying off. So there's a seal around the outside of this upper cup here. We'll just set that down here and push down. Then we'll lift it back up, push down again. So as you can see, it inflates not just the top of the glove, but everything down below here around your wrist and the bottom of your hand anyway. And then you can listen and look for damage, and that really is a better way to go. This was a fairly expensive thing to buy. I can't remember the price. I think it was like $300. But it does a much better job of inflating the glove. Now remember, you are putting your life in your own hands every single time you put on these gloves and go work on some high voltage circuit. So if you don't test these every single time before you put them on, you are literally taking a chance with your own life. So let's put these gloves on the way they're intended to be used. So the first thing is we have a cotton inner liner glove that we wear. So we'll just put these on first. This gives us a little bit of an air gap between the rubber type glove and your hand. It gives it room to breathe. So the cotton gloves on, and then the high voltage rubber gloves, and then to protect those gloves from getting destroyed on the first sharp thing you touch, we wear these special outer gloves. There's a cinch strap right here to cinch that up. And the rule is always wear two gloves. Never just do one and think you're going to be okay with your other hand, because you never know when you're going to need your other hand and you'll forget that it's not protected. Or maybe you'll slip and put the other hand down to support yourself and it'll be on something you shouldn't be touching. But now I have on some tested gloves for leaks. They're within the certification range as far as the law and the standards are concerned. And I have some leather outer gloves. These leather outer gloves are dirty because we've used them in class many times. Just don't forget that as they get dirty, they become conductive. So these really need to be cleaned. periodically to prevent the outer glove itself from being the conductor that you're trying to avoid. All right, now with 3 layers of gloves on, it's hard to manipulate small little bolts and tools, but with a little practice, you can get that done. Now, personally, I've worn this combination of gloves for close to an hour before in class, doing certain tasks on vehicles, and I've been comfortable the whole time. But without that inner cotton liner, it's like 5 minutes and I'm dying. My hands are so sweaty, I gotta get them out of there. All right, so let's take those off. Now, for those of you who maybe don't want to wear cotton inner liner gloves, Salisbury does sell what's called glove dust. And it's this powder that you can put on your hands and then put on the glove to try to keep the sweat down. Personally, I don't like this as well as I do the inner liner, but with this, you've got 1 layer less, and so maybe it's a little easier to manipulate bolts, nuts, tools, sockets, whatever you're doing there. Okay, so that is the personal protective equipment as far as on your body. But now, let's take a look at some of the additional personal protective equipment as far as tools. Okay, as far as tools and other equipment for working on hybrid and electric vehicles, you need to get yourself some orange cones. These have some labels on them that say danger or high voltage, but at least orange cones. We are going to use the orange cones to surround the vehicle to let people know when you have opened up the high voltage system. Let's say you're changing the battery or a contactor or a computer or whatever it is, or where there may be some high voltage lines that are exposed and open, where anybody could walk up and touch them. You need to have these cones all around the car, maybe even one on top. And then they also recommend that you get some hazardous area or caution tape and stretch that from cone to cone. And this is not really to protect you. This is to protect other people. Somebody a customer, for example, that left something in their car and they come back to get it, and if you didn't have the area marked as caution, it's possible that they could get hurt touching the wrong thing or causing a problem to occur. So safety cones and hazard tape. All right, the next thing you need in your shop area for working on high voltage vehicles, especially if they have nickel metal hydride batteries, is right here behind me. I've got a Class D fire extinguisher, this yellow fire extinguisher here. And a Class D fire extinguisher is for combustible metals, like nickel metal hydride. So if for some reason there's a battery fire, you could use a Type D fire extinguisher on them. They are very expensive fire extinguishers. I think this one was around $500. But at least you've got something that can put out a metal fire. A Class A, B, or C fire extinguisher, I understand, doesn't work on those. One other big piece of equipment that I have right here is called a hot stick. This is from Salisbury also. This hot stick is rated for 1000 volts also, and the purpose of this hot stick is, well, one of the rules on working on hybrid and electric vehicles is that you never do it by yourself. You should always have somebody else in the shop with you. And if for some reason you get electrocuted, if somebody else comes over and tries to help you, there is a possibility that they also could get electrocuted. So this hot stick, the handle is non-conductive, and the hook here is well, it's a body hook. You see these at what looks like these at a swimming pool, but it's to pull somebody away from the high voltage if they are being electrocuted. So a hot stick is another tool that you're going to need. Okay, let's talk about high voltage hand tools for a moment. I have several high voltage hand tools here on the table that I want to look at. The first one is just a set of screwdrivers. This is from a German company. The name is spelled W-I-H-A. I don't know if the W actually sounds like a W in German or if it's a V, but these are safety insulated 1000 volt protection coated screwdrivers. So they have a insulated handle, and then they have a coated shank with a insulative coating, and then a flat screwdriver tip, and then Phillips screwdriver tips. So these are coated tools. You can get these, I think we got these through Grainger. I'm sure there's several sources for them. So that's a coated screwdriver. Then we have a metric socket set. This is also from a German company called Knipex, and these are also coated tools. So we have a coated 1000 volt insulation, as long as it's clean. These always have to be clean and dry for that insulation to work. 3/8 inch ratchet here. We have coated extensions, just like that. And then coated sockets, anywhere from 10 millimeter up through 19 millimeter. And so that is a coated ratchet, extension, and socket set from Knipex. All right, Knipex also makes a set of coated hand wrenches. So I've got a set of open end hand wrenches. It just has one end that's open, that goes from, it looks like 8 millimeter, looks like we got a 8, 10, 13, 14, 17, 19, 22, and 24 millimeter hand wrench in here. And once again, these are coated tools. So it's a steel tool with a high voltage coating over the outside of it. All right. I have to kind of poke fun at some Toyota service information I've seen in the past. They just told you to get a roll of electrical tape and wrap it around your socket. And, there's so many different types of electrical tape, but some that are more resistive than others. And anyway, I think they are finally getting rid of that ridiculous procedure. I can't believe they, of all people, are doing that. But anyway, there are high voltage tools out here, and I do not recommend wrapping tools with electrical tape. All right, now the next set of tools that I have here are from Snap-on. So I've got a socket set here from Snap-on. These are not coated tools. So yes, they have steel shanks down in them for both the drive side and the socket side, but in between there is no steel. And that's why they're so thick here. It takes whatever material they're made of, it takes a lot of it to handle whatever maximum torque they're rated at. But this goes from 10 millimeter up to 19 millimeter in coated, or not coated, in composite sockets. And then they have what looks like a child's toy. This is a snap-on 3/8 inch ratchet, and it has no metal in the handle itself. It has, of course, the metal ratchet part in the top there, but this is a composite ratchet also. And surprisingly, these aren't any more expensive than a regular snap-on socket set and ratchet. Here's another tool that looks like a child's toy, a pair of needle nose pliers. And yes, these are snap-on pliers. Part number C97CP, but it's just a set of total composite needle nose pliers. All right, then extensions. Let's say you need an extension for your ratchet. Well, we've got a long extension right here. This is a composite one. It tells us to not immerse it. Don't coat it with conductive fluids. Keep it clean and dry. And so we've got a really long ratchet or extension, and then we've got I think that's a 12-inch one, and then we've got a 3-inch and a 6-inch long extension here also. These look like a carbon fiber wrapping on them. These have metal inserts on each end, but no metal in between here. All right, they have a breaker bar here, and the breaker bar has a composite section in right here that insulates the head from the handle. So a 1/2-inch breaker bar. And then this is a coated, these are not composite, this is a coated set of pliers rated for 1,000 volts from Snap-on. I've got a little 1/4-inch drive bit holder for like a power tool. I've got a 1/4-inch extension, and then I've got a spring-loaded screw extractor for a standard screw and a Phillips head screw right there. And then the last tools that I have here, as far as hand tools, are screwdrivers also. And if we compare these to the first set, you might think that they're the same, but they're not. The Snap-on ones are not coated metal shanks. This is a composite shank and just has a steel insert in the end down here, is my understanding. So they've got number 1, 2, and 3 Phillips and 1, 2, and 3 flathead screwdrivers here. All right, so there's a variety of hand tools available for automotive high voltage work. Snap-on is the first one that I saw that had high voltage tools. I haven't checked with anyone else because honestly we don't get anybody else coming by the school very often trying to sell us tools, where Snap-on has been there regularly year after year after year. For those of you who follow my channel, you may notice all the Snap-on tools we have, and I really like Snap-on tools, and I know they're expensive, but the service end of that goes with it also. Somebody there when you need an exchange, and they've always been there. All right, a couple other tools and equipment to look at. I got a bag of insulative caps, and these are from Kentmore Tools. It's part number EL48569, and all this is just a covering that would go over the end of a high voltage wire. So for example, if you read in the service information on some vehicle manufacturers, especially Toyota, if you unbolt a high voltage wire, even though there's no voltage on it, they'll tell you to wrap the end of it with electrical tape. Well, you don't need to wrap it if you've got one of these. You just stick this over the end of it and protect it. And so I've got a lot of these, a couple of sets of these that I use that work really well. So these go over the ends of high voltage cables. All right, now let's talk about multimeters. I'm a big Fluke meter fan. I think they build some fantastic meters and are just good quality, last many years. I've got some multimeters here that have been here as long as I have, and I'm in my 27th year here from Fluke that still work. But you have to be very picky about the meter that you use when you want to work on hybrid and electric vehicles. So there's a rating, it's called a Category 3 rating, that your multimeter must meet in order to be safe to even hold in your hand when you're taking voltage measurements. All right, the Fluke 87 meter is rated as a Category 3 meter. And so if we look right on the front of the meter, right between the black input terminal and the red input terminal to the right of it, it reads Category 3, 1000 volts. So that means that this meter, holding it in your hand, and the meter itself can handle 1000 volts without burning itself up, without shocking you through the meter case itself. The meter leads themselves also say right on them Category 3, 1000 volts. And so you have to have clean meter leads that are in good shape, along with a multimeter, and it doesn't have to be Fluke, but any meter that's rated Category 3 would be good enough to work on a hybrid and an electric vehicle. Now, we had several of these meters donated to our school here a few years ago, a whole bunch of them actually. I think they gave us 12, which was really nice, and thank you, but these are all Category 2 600 volt meters. And we couldn't recommend to any of our students to buy one of these because they're not certified to the Category 3 standard. So look at your multimeter. If it's not rated at a Category 3 on the front of the meter, chances are it's not Category 3. Now, there are some older Fluke meters that don't have any categories on the front of them, but if you look up in the owner's manuals that you can find online in a PDF document, it'll tell you that some actually were Category 3, some were Category 2, and so on. But find your owner's manual when in doubt and see what it's rated for. Several years ago, I taught a night class where I was describing the advantages and benefits and how nice these Fluke meters are. And I had a student say, well, I don't need to spend $300 on a multimeter. I bought one for $3.95 at Harbor Freight. And I said, well, bring it in. We'll check it out. We'll see how good it is. And so he brought it in. It has no category ratings at all on the meter itself. The owner's or the instructions that come with it say nothing about category ratings. The meter leads themselves say 1000 volts, but there's no category there, and I wouldn't trust it at all to be safe to use on high voltage. So if it doesn't have that rating, that means that just holding the meter leads in your hand or the multimeter in your hand while taking a measurement on a high voltage circuit, there's a possibility that it could do damage to the meter or even jump through the case of the meter and shock you. So get rid of the cheap meters. Find yourself a meter, no matter the price, that has a Category 3 rating. All right, so we'll get the useless meters out of the way for hybrid and electric work. And our standard Fluke 87 meter here is just fine for almost every single reading or measurement that you need to take on a high voltage hybrid or electric vehicle. This is a great meter and works great. There is another meter, though, that you will also need for hybrid and electric work. Fluke makes one, and other multimeter manufacturers make them also. And this is called an insulation tester multimeter. This is the Fluke 1587. The Fluke 1587. So what this is this is pretty much the same multimeter that you have here, but it has some additional features that allow it to test for really, really high resistances. You could call this a Megohmmeter, would be another term for that. And how does it do that? Well, the Fluke 87 here uses like all multimeters, applies a voltage to a circuit that it wants to check the resistance of. And when it applies a voltage through the 2 meter leads, current will flow through whatever component you've touched the meter leads to, and how much current goes through it is inversely proportional to the amount of resistance. So in other words, high resistance gives us low current, and low resistance gives us high current. And then it does an Ohm's law calculation and gives us a resistance check here. The voltage that the Fluke 87 meter uses to measure resistance isn't anywhere near the voltage that is normally used in those circuits, and so it doesn't have enough power to measure that resistance accurately. But this meter, the Fluke 1587, can apply up to 1000 volts while measuring resistance to check for short circuits in the stator windings of a hybrid or electric vehicle. All right, so the way that happens is it has a unique meter lead here. So this meter lead has a button on the end of it right there, and it has a strange electrical connector right there, and that strange connector plugs into the meter right here. And then we're going to take our black lead and we'll put our black lead in the common input terminal right there. And now we have our 2 meter leads, the red one and the black one. So now when we want to check to see if the stator windings are shorted to the stator frame of the motor, we can use this meter. Now normally that would be an open circuit, and so any multimeter would show OL for overload or out of limits, whatever definition you want to use there. But it overloads at 20 megohms, 20 million ohms is all it can measure. This one can go up into, I forget the spec on this one. I think it's 5 gigaohms, 5 billion ohms it can measure with the high voltage there. Okay, so I brought over a stator winding for motor B from a Chevrolet Volt 4ET50 transaxle that I have over here on the bench. And the stator windings are these copper windings here. There are 3 coils of wire here and 3 connections over here on the side. With the regular Fluke 87 meter, we are going to check to see if any of these 3 windings have rubbed through or shorted to the outer case, the housing itself, because none of those should do that, because if you do, you'll have a shorted stator and the motor will be real jerky or it won't work at all. So if we go from one of these 3 terminals here to the case, it should read OL, and it is. So that indicates that there's an open circuit. But that OL is only measured with a small amount of voltage that this meter puts out. So if we take the Fluke 1587 meter and take out our resistance checking probe and put in the multimeter probe instead over here, what we are going to measure is the voltage that the Fluke 87 uses to measure resistance. So we'll just hook red to red, black to black. The Fluke 87 is on ohms. The Fluke 1587 is on volts. So that's telling us that the Fluke 87 is using 2.7 volts to measure resistance on that stator winding. 2.7. And this thing can run close to 700 volts. It has a 380 volt battery, I believe the volt does. So 2.7 volts is pretty unrealistic. And so let's get this Fluke 87 out of the way for a moment, and we'll put the resistance checking meter lead back in over here. And now we will go from the stator case itself here to one of the leads. Let's flip this to what's called insulation test. So over here on the right hand side, right there, we have orange numbers that read 50 to 1000 volts insulation. So we're not going to put it on ohms. We're going to put it over here to insulation test. And then when we're ready to test the insulation, or test what should be the super high resistance between the stator winding and the housing, we're going to press that orange button, or we can press this button here on the end of the meter lead. So I'm going to put that right here on the copper conductor. Just kind of lay it here sideways, and let's see, let me get the meter positioned where we can read it. Okay, here we go. So it's telling us it has 2.2 gigaohms with 1000 volts applied. 2.2 gigaohms. 2.2 billion ohms of resistance between these two. And each vehicle manufacturer will have a minimum amount of resistance allowed. And if it's higher than that, then we're okay. So whatever that may be. Now that was with 1000 volts. There's a test voltage button right here where we can switch to 50 volts, and then 100, 250, 500, and 1000. So 50, 100, 250, 500, and 1000. Now 1000 is too high to use on a vehicle that doesn't use a 1000 volt electrical system. So we have to pick the next lowest voltage, which is 500. So all the tests I've seen for checking for shorted stator windings use the 500 volt scale. So we'll switch this to 500 instead, right there. And on 500 volts, I'll touch right here. I'll press the button on the lead, and Now we've got 550 million ohms. 550 megohms at 500 volts. So the amount of voltage applied affects the resistance. So still there's a minimum specification there. Now this is more realistic, and that's why they're using this meter to check these, because these don't run on 2.7 volts that the other meter uses to check resistance. So that's why we have the insulation tester, or Megohmmeter as other meter manufacturers call it. So Chrysler, General Motors, even Toyota call for this Fluke 1587 insulation tester. I'm sure others do also, because it seems to be a wonderful meter. All right, well, we've talked about personal protective equipment, the specialty tools, and multimeters that are all related to service work on hybrid and electric vehicles. We've talked a little bit about your shop. You've got to have a fire extinguisher, the hot stick body hook. You should never work alone. Always have somebody nearby. Keep everything clean. Use the cones around the car, the tape around the car to keep customers away from it. These are all basic minimum requirements for safe operation, safe diagnostic and service work on a hybrid or an electric vehicle. And I can tell you that it's almost impossible to accidentally shock yourself working on one of these. Chances are extremely slim. And even more so if you're using the proper personal protective equipment. Now that's true unless there's a check engine light or some sort of a warning light on, and then look out, because there could be a short somewhere that's electrifying something that you don't think would normally be electrified. All right, well, thank you for watching.